Hello dear makers. So in this video we are getting inside the Wishtree board schematic and pin maps. So I am Bapaditya, the program manager for Wishtree IoT development kit. So let us begin. So here's the schematic. If you want a clear PDF, what you can do, you can go to our website. So how to find our website? Very easy. You can go to Google and then you just type WiseThings, and remember the last letter is Z and not S, so you can find us at the top. Okay, so here's WiseThings, and you can go to this page and then you need to get inside Wishtree menu. Okay, so here is the Wishtree menu. Now I am going inside Wishtree. So if you have a look at the page, you can find a photo of the board. Then if you want to buy, here is the buy links. You can payment through here. Here is a small project video, a compact project video. Have a look for yourself. And here at the bottom you can see all the required documentation, quick reference, technical manual, schematic, API document, and a link to our YouTube channel. So let me click on the schematic. So here you can get a very clean PDF of the schematic. Okay, so this is how you get the schematic. Okay, and you get all the guidance from here. And then let me go back to the PPT. Okay, so this is how you get the schematic, and next we go ahead, move ahead. So first of all, I would like to show you the jumper settings. So first one is the regulator. So we are using for powering purpose this board, we are using two regulators to power the ESP8266 or ESP32. One is a 500 milliamp, one is 250 milliamp. This is keeping in mind the deep sleep low current requirement, so you can use any one of them. So this J8 jumper is actually connecting either this regulator or that regulator. So sometimes to make two voltages available on the board, like 3.3 volt and 5 volt, we replace one 3.3 regulator with a 5 volt regulator. In that case, what we do, we don't give you this pin so that you don't accidentally like connect your ESPs with 5 volt, but you get 5 volt available on this pin. Okay, so this side is always a 3.3 volt jumper, 3.3 volt regulator, which is this one, and this is the other regulator which we sometimes use 5 volt regulation. Okay, then let us go ahead. What is next? Next we have this program switch. Either you flash or run. So I am talking this all from this schematic. So these drawings are just clips that I have taken from the same schematic. Okay, so to program the board, so for the normal run, what happens, the GPIO 0 is connected through a 10K register to high, so it normally goes into run mode. So here is the jumper. Okay, so this is always required for running or even in the program mode. So if you want to put the board into flash mode, what you need to do, you need to keep this switch 4 pressed. In that case, the GPIO 0 is grounded, and you switch on the board. In that case, it will enter the program mode. Okay, then what's next? Next is reset switch, SW3 here. So reset is just momentarily putting the enable pin to ground. So that is what is done when you press switch 3. Otherwise, it is normally pulled up to high. Okay. And then this is your analog in. D in means stands for direct in. So if you are using analog sensor, what you can do, you can put, or you are you are sensing the battery voltage available, you can connect your battery directly to this D in pin, and there is a voltage divider available on the board, because the ESP8266 or ESP32, the respective pins are A0 and 34, cannot tolerate more than 1 volt or 3.3 volt. That is why if your V in or D in, this should be D in, or V in. Why I marked V in? Because of if you are using your battery voltage to sense the percentage of battery remaining in the device. So in that case, it is marked as V in. Otherwise, you can directly put any analog sensor here. Even if the voltage is high, it goes through this voltage divider, and then finally it reaches the A0 of ESP8266 or 34 of ESP32. And if you don't want to use this, you can just simply remove the jumper. You simply remove this J1 jumper, and you can find your A0 or 34 pin in the bottom. Okay, and you are free to use that as well. So what is next? Next is GPIO 4 for ESP82. So the anything this is before the comma is for ESP8266. So pin 4 of ESP8266 or pin 21 of ESP32, these are actually I2C pins. So these are having some jumper settings here. It is, you can see the jumper J7 and J6. So here is the jumper J6 and J7. So under J6 you can find pin number 5. You can also say pin number 5, 22 for ESP32. And if you put this jumper here, then what happens? You get your pin number 4 and 5 or 21 and 22 here as well. Okay, you can see the writing here 4 and 5. Okay, but if you want to use them directly and not here at this point, then you can just remove the jumper and you have your pin number 5 at the top and pin number 4 also at the top. And when you put the jumper, your pin 4 and 5, or you can also alternatively say 21, 22 is available here as well. So these are the I2C pins. So these are available here. These are useful many a times when say you are using some I2C attachment here. So you can directly, if you remove the jumper, you can directly connect your jumper wires from here to this connector, so to power and communicate through I2C with this attachment. Okay, so let us move ahead. So here is pin number 14. This has also got a jumper setting. Okay, so this is pin number 14 for both the boards. So it is said only 14, no comma and 2 values. Okay, so sometimes we can power up another IC. So if you are using a second IC here, we can power up that through GPIO 14 if you want, by engaging this jumper, this 14 to I2C jumper, which is, so you can engage this jumper here, or if you want to directly supply 3V through to your another IC, you can engage this jumper here. The IC2 is normally installed on this attachment 1 and 2. Okay, this is mainly done so that in deep sleep, when the board is under sleep, the GPIO 14 also go low and your attachment or the IC2 is powered down, so that you can have a ultra low current deep sleep. Okay, next let us go ahead. Here is the LED. So you can LED is this LED is connected to pin number 12 through jumper 4 and a 100 ohm, or sometimes we use 200 ohm resistor. Okay, so if you are planning to use your pin number 12 freely, then you can just remove the jumper and you can use pin number 12, which is at the downside. Okay, so this is how you can use the LED, or you can directly use the pin number 12 also. And then we go to GPIO 13, the mode switch. GPIO 13 is connected to the mode switch. This is GPIO 13 because only 13, because for both ESP8266 and ESP32 it is GPIO 13. So you need not do any changes in code. So only in the case of this I2C you need to make a change of pin number in the code if you are switching from ESP8266 to 32 or vice versa. Otherwise it is the same pin number for LED. For this powering up or this mode switch, because both are GPIO 13. So what it does, GPIO 13 through jumper J2. So this is the jumper J2 is pulled down normally, and if you press down the switch 2, then it gets a high connection. So this way you can like attach an interrupt, or you can do, so we use it for mode switches. Like if I want to switch this on like in config mode, then I press this button, press down, so when switching on the board, and then GPIO 13 we sense the GPIO 13 status when switching on the board, and if you find it high, then we put it into a different mode. And using this same button, using long press, short press, we can also like get the device into different modes. Like so there is a YouTube video to how I have used the same button with different long press, short press to put the device into different modes. The codes is also there, and it is depicted very nicely there. And if you are like willing to use GPIO 13 freely, you just need to remove jumper 2. So once you remove jumper 2, you find GPIO 13 in the left side. Okay, and let us move ahead. What else? This is a reset jumper. This is not in the drawing. This is a reset to pin 16 jumper. This is mainly used for ESP8266. So after deep sleep, if you need to wake up automatically, you need this shorted. So if you are using deep sleep and automatic wake up, please keep this jumper engaged. Okay. And now I am getting, so after all the jumper settings are described, so let me open up this schematic again. So here all the jumper settings now I have separately described with the photo, right? Now what we are doing, we are now looking at other than the jumper, what are the pins available that we have here. Okay, so for that I have a very good comparison with ESP WROOM32. So if you see, these yellow pins are settings pins. Like here, GPIO 2, 15 and 0 are used for setting up the board, like flashing and other things. So we normally don't disturb them. They remains there. These red ones are internal reserve pins for SPI, so we don't touch them. They are like this. And these green pins are actually with those jumper settings. So these green pins are multifunction pins, as I already has explained in the jumper settings. So these are used for multiple purposes. You can see also serial pin. This is for, this blue one is RxTX for code upload and debugging, and all the other unmarked pin are directly open to you for your use. You can use these pins as you want. So if I have a look at this Excel sheet, so you can see I have this ESP32 view here. So this is how it is fitted on top of the Wishtry board. So the left flank, this pin, so here is the left flank, and the right flank is this pins. So D is direct pin, M is multifunction pin. So if you see, these pins are already engaged in something else with jumper or maybe internally reserved, but these D pins, direct pins, are available for you to do any of your work. You can directly use them. And how they are open there, so let me again go back to this PPT. So here are the pins that are directly exposed to you, and here are the pin numbers. So 4, 16, 5, why I marked them? They are pin number 4 of ESP32 and not ESP8266, because these are common pin numbers. These are used in both the boards. So the pin numbers marked here are for ESP32, that is why I written like this 4-32. Otherwise, other pins are like unique pins. These numbers are available on ESP32 only. So these are the pins. When you are using ESP32, you can use these pins directly for any of your peripherals. And what are the other pins? So here I have already shown 4/21, 5/22 available, and RxTX pin is available here. You can provide your VIN here when you are programming through a separate USB, and you don't have this USB to TTL module mounted here. You can use this VIN and ground. So this is where you have these pins. Then other strapping pins, which we are not using, but I have anyway given a test pin for if you want to use it. They are available here, pin 2, pin 15, and reset. I didn't make the pin 0 available because that is engaged for flashing the board. Okay, and then what else? You have some V-ins, so you can power up the board from V-in also here. Whatever you supply the board, like if you are supplying with 12 volt or 9 volt, you will get that same voltage available here. So sometimes we use this V-in to run the GSM module, because GSM module needs a higher current, like 1.5 amps to 2 amps. So sometimes you can directly supply a 5 volt of high ampere rating, and you can drive your GSM module directly from there. Okay, so this is how V-in is used. So you can also, like if you are like want to sense the battery voltage, how much left, you can short this V-in to your analog in, and you can sense the battery voltage there. Okay, what else? We have made available a few spare 3B3 pins. So if you are using with some peripherals, you can connect to 3B3 pins here. This is the 5 volt pin. If you are using something 5 volt, some sensor that needs 5 volt, you can get the 5 volt from there. Here is a pull up. If you need any pull up for some work, you can use this pin. This is a pull up, 10K pull up for 3B3 volt. Okay, and here are some spare ground pins that you may use when you are doing some project. So this board is done like after all the consideration of all the kind of projects that we do. So we have made all the possible utilities available on this board so that you can use it in any of your project, and you can do complete your compact project very easily. Okay, so this is it. So with this I will close it here. So here is the link to our website where you can find the schematic and all other documentation like pin map and other jumper settings, etc. And here is the YouTube channel where you can have a look at our videos. All kind of communications like Wi-Fi, Bluetooth, BLE, GSM, LoRa, all are explained there with nice videos, and you also have the Arduino code links there. So with this I close it here. Thank you for your time. I wish you all the success in your life. Thank you very much. Bye bye.